Okay, so my name is Shreya Agrawal, and today I'm going to be presenting my honors capstone project, which is called Relationships Between Hippocampal Myelin and Memory Performance in Older Adults. This is a project I've been working on for the past year and a half with guidance from my faculty mentor, Dr. Ilana Bennett. Okay, so just to start off, I wanted to give some background on exactly what myelin is and its role in the brain. So myelin is a neural substrate that is made up of fatty glia that wraps around axons. So pretty much it serves as an insulating factor for the axons, and it speeds up signals between the brain regions that it innervates. It is found in both white matter and gray matter. So if you look at this image on the right-hand side, within white matter, it's found as insulating these long range axons that go from each brain region to the other. But within gray matter, there's two different ways that myelin is found. So the first one is depicted in this image. It's kind of found as like the ends of long range axons between the white matter and gray matter boundary. And the second way is within gray matter itself as more short-term axons. So within specific structures in gray matter that have their own myelin, there's axons that are going within those structures. And so the hippocampus is an example of one of those structures that has its own myelin. So as aging occurs in humans, there is a loss of myelin, which ultimately slows down the speed of signals in the brain. And this ultimately can negatively affect cognition. So some background on episodic memory. Episodic memory is the ability to recall details and information about events, like what happened, where it happened, things like that. And that is called free recall. So without any kind of cues or hints to help trigger those memories. And the hippocampus is the primary brain structure that is involved in episodic memory. So if you look on the right-hand side, this is an image showing the hippocampus and where it's located in the brain. And it is a bilateral structure, meaning it's found on both parts of the brain, so the right side and the left side. There are several ways to test episodic memory, and one of them is the Ray Auditory Verbal Learning Test, or RAVALT, and that was the specific episodic memory test that we used in this study. Some background on myelin mapping. So myelin mapping is a technique that is used to measure myelin content throughout the brain. And there are several ways to create this myelin map, but one of them is the T1 weighted, T2 weighted ratio. And we chose to use this specific myelin mapping method just because it is the most accurate and it is a quicker way of generating it than other techniques out there. And so this is going to sound a little bit more technical, but the way that the myelin map is exactly generated is you have two images. You have the T1 weighted image and the T2 weighted image, and you end up overlaying them to create this myelin map. And so the T1 weighted image darkens gray matter and lightens white matter, whereas the T2 weighted image will darken white matter and lighten gray matter. So when you overlay these images, it creates a myelin enhanced image so that we can look at the myelin content in the brain. So if you look at this image, you can see the gray matter, white matter boundary. So that's another benefit of the myelin map is you can see the boundary between the two. And then the areas that are brighter or more white, for example, over here, are areas that have greater myelin content. And so kind of where this study comes in with myelin mapping is that previous studies have only shown sensitivity of myelin to brain aging, but they have never really actually looked at the relationship between myelin and memory performance or myelin and diffusion imaging, which is the next thing that I'm going to go into. So some background on diffusion-weighted imaging. It's another type of MRI imaging, and there are several ways to do it, but the way that we chose is naughty metrics in this case. And what it does is measures brain tissue microstructure based on water movement within the brain. And so lower diffusion metrics or naughty metrics is related to better brain microstructure. And so recent studies have found a positive relationship between age and diffusion metrics, as well as a negative relationship between age and memory performance. So in this study, we wanted to look at the exact relationship between diffusion metrics and memory performance to see what that relationship is and to see where myelin comes into play within that relationship. And so a little bit more about the purpose of the study. We had two primary goals. The first one was to examine the contribution of hippocampal myelin and diffusion metrics to episodic memory performance. And we predicted that greater myelin content and lower diffusion metrics would contribute to better memory performance. And then the second goal of the study was to examine the contribution of hippocampal myelin to diffusion metrics. So that kind of sets up this image over here, which is the relationship between diffusion metrics and memory performance. We basically wanted to see where myelin plays a part in that. We wanted to see if diffusion metrics capture myelin within those images and if it helps to explain the relationship between diffusion metrics and myelin memory performance. So to get more into the methods of our study, so we had 40 older adults that were between the age of 70 and 80 years old, and they went through a cognition screening process in order to ensure that they had normal cognition when coming into our study. So after that, we conducted the episodic memory test using the Rayvault test, and that tested for 3 different types of memory performance. This was immediate recall, delayed recall, and recognition memory. And then we went ahead and got their MRI scans. So we gained 3 different types of MRI images. The first one was the T1 weighted image. The second one was the T2 weighted image. And then we also got the diffusion weighted images. And so the T1 and T2 weighted images were used to generate the myelin map. And then the diffusion weighted image was used to extract our naughty metrics in order to look at the intracellular dispersion and free diffusion within the brain. And then the last part of our methods was to actually segment the region that we were interested in, which is the bilateral hippocampus. So we were able to zone in and gather all of our data specifically for the hippocampus instead of just the whole brain. And so getting into the results, the first set of correlations that we ran were between myelin content and memory performance. And so we did find a significant result within these correlations, and this was between right hippocampal myelin content and Rayvault immediate recall. And so this was actually a negative relationship, meaning that lower myelin content relates to better memory performance. Because this relationship had never been studied previously, we weren't sure exactly which direction this relationship would go, but based on the fact that greater myelin content is better, we expected there to be a positive relationship, but we actually saw a negative relationship, which could be because of a few reasons. One of them is that the episodic memory test that we used, which was Rayvault, could be more sensitive to myelin degradation. And because of that, we ended up seeing a negative correlation between the two. And then the next set of results that we saw were between diffusion metrics and memory performance. So we also found significant results between right hippocampal dispersion of diffusion and Rayvault immediate recall. And I just wanted to point out the p-value for this, which was very, very low, showing that it was a very strong correlation. And this was also a negative relationship, showing that lower dispersion of diffusion relates to better memory performance. And this was what we were expecting to see, because lower dispersion of diffusion means better microstructure, and that would lead to better memory performance. So this did correlate with our predictions. And then our last set of results was between myelin content and diffusion metrics. And we had 2 separate sets of significant results for these correlations. The first one was between right hippocampal myelin content and intracellular diffusion in the right hippocampus. And this was in the positive direction, meaning that lower myelin content relates to lower intracellular diffusion. And then the second set was a similar direction. It was also a positive relationship, also in the right hippocampus. And this was with dispersion of diffusion. So this meant that lower myelin content related to lower dispersion of diffusion. And for both of these results, we again were not sure exactly which direction these correlations would go, just because these have never been studied in the past. But we were surprised by the results just because we were expecting there to be a negative relationship. But the fact that lower myelin content related to lower rates of diffusion could be attributed to the fact that in older adults, there is a loss of myelin, but that empty space could be taken up by other neural substrates. So for example, there could be neural inflammation or swelling of glia or something like that that kind of uses up that empty space and keeps our diffusion rates low. So these again were very low p-values. They were statistically significant and very strong correlations. So we were excited to see these results. And then the last set of results was our mediation analysis. So based on all of the previous results that we had found, it set up the mediation analysis to see if myelin content was captured by diffusion metrics and if it helped to explain the relationship between diffusion metrics and memory performance. And so once we ran this mediation analysis, we did find that myelin fully mediates the diffusion memory relationship, which was a really exciting finding just because this has never been discovered before. And so we were able to confidently say that myelin is captured by dispersion of diffusion specifically, and it helps to explain the relationship between dispersion of diffusion and Rayvault immediate recall. So just to summarize, this study was able to validate the negative correlation between diffusion metrics and episodic memory performance. And we were able to identify the new finding that hippocampal myelin is not only captured by diffusion imaging, but it also helps to mediate or explain the relationship between diffusion metrics and memory performance. We do have a few limitations that we want to acknowledge. The first one is that we had a relatively small sample size of 40 older adults. This is definitely something to acknowledge because our results had more weight from each participant. So each participant's data could skew our results one way or the other, but we did still have a pretty big group at 40 older adults. And another one is quality control. We did assess each participant's MRI images and make sure everything was looking good, but there is a chance that we had slight excess in cerebrospinal fluid, or that when we were overlaying the images, there was a slight misalignment, which also could have affected our results. However, the main takeaway from our study was that age-related loss of hippocampal myelin does contribute to worsened episodic memory performance in older adults. And yeah, I just wanted to thank my faculty mentor, Dr. Alana Bennett, for all of her help and guidance. I wanted to thank the Lonnie Lab for all the resources and aid that they provided me, as well as the University Honors Program for this opportunity. And last but not least, my family and friends for all of their continued support throughout this journey. But yeah, thank you so much for listening, and I'll be happy to answer any questions that you guys might have.
Thank you for that really